Ever wished you had like a personal assistant, to help with just everything? Writing emails, planning your day, even like learning new stuff.
And one that could adapt to, like, your own learning style.
Exactly. Well, that future, it might be closer than we think.
Thanks to the world of large language models.
Or LLMs for short.
These AI systems, I mean, they're already doing some pretty amazing things.
They can write stories, translate languages.
Answer your questions in a way that feels almost, well, human.
Almost human. Yeah, but there's a catch.
They are huge EE,
We're talking billions of parameters, massive amounts of computing power.
which makes them, well, really expensive to train.
And it really limits who can actually use them.
Exactly. Imagine if LLMs were more accessible, though. Think personalized education, like tailored to each student.
More powerful research soon.
Even creative applications we haven't even imagined yet.
That's what makes this research paper we're diving into so fascinating.
It's called Tailored-LLaMA.
And it's all about making these LLMs more efficient, more adaptable.
This paper tackles a core challenge head-on. How do we make these AI systems smaller, more accessible, but without sacrificing their performance?
Okay, so let's unpack this.
The paper focuses on a specific LLM called LLaMA.
And the key idea here is pruning.
Think of it like tending a giant tree.
Okay.
Sometimes you need to carefully trim away some branches, helps it grow stronger, more efficiently.
So not like chopping the whole tree down.
No, more like strategically streamlining it.
Gotcha.
Structural pruning is what Tailored-LLaMA uses
Right.
to pinpoint and remove parts of the LLM that are less critical to its overall performance.
So it's like figuring out which parts of the tree are essential for, bearing fruit.
And which ones are just using up resources.
I like that analogy.
And the results are pretty impressive.
Yeah.
Absolutely. They were able to shrink the LLaMA model by 20% or even 50%
Yeah.
without significantly impacting its ability to perform tasks.
I had no idea you could make them that much smaller and they'd still be so powerful. That's incredible. Smaller size isn't the only trick up Tailored-LLaMA's sleeves, though, right?
Right.
The researchers also explored the power of something called prompt engineering.
Think of it like giving directions to a
Nah.
self-driving car. The more precise your instructions, the better it can navigate to your destination.
So instead of asking like a vague question, like tell me about the universe,
Right.
you'd give the LLM a more specific prompt, like explain the 3 most mind-blowing facts about black holes.
Exactly. And the research shows that using these task-specific prompts, they can drastically improve the accuracy of a pruned LLM.
Interesting. So the researchers, what they did was they gave the LLM different prompts for various tasks.
Right.
And they consistently got the best results when the prompts were tailored to the specific task.
Exactly.
Yeah, that's so interesting.
Yeah, it highlights the importance of understanding how these LLMs process language. It's not enough to just, throw data at them.
Right.
We need to learn how to communicate with them effectively to really unlock your full potential.
Totally. So we've got pruning to make these LLMs more efficient.
Yeah.
We've got prompt engineering to make sure we're communicating with them effectively.
Uh-huh.
But there's one more piece of the puzzle, right?
Right.
Few-shot learning.
Imagine you're trying to teach someone a new skill, right? Instead of overwhelming them with tons of information,
Yeah.
you just show them a few key examples and they pick it up quickly.
So it's like giving the LLM a crash course in a new subject.
Exactly.
I like it.
So in this case, the researchers trained the pruned LLMs on small, task-specific data sets.
Right.
This allowed them to achieve impressive accuracy in a really short amount of time.
And the results, they were pretty remarkable, right?
Yeah.
They took a model that had been pruned by 50% and were able to restore it to almost 87% of its original performance in less than an hour of training.
Yeah, it's a testament to the efficiency of this approach, and this is just the beginning.
So what does this all mean for our listeners? Why should they care about these, seemingly technical details?
Well, these advancements, they have the potential to change the way we interact with AI in some really profound ways.
We're talking faster, more affordable AI tools.
Right.
Tools that can be personalized and adapted to specific needs.
Precisely. Imagine personalized tutoring systems that adjust to your learning style.
Wow.
AI assistants that are not only more accurate, but also more efficient.
Okay.
Even new frontiers for creative expression using AI.
This is all starting to sound less like science fiction and more like a glimpse into the near future.
Yeah.
But before we get too carried away with the possibilities, let's take a closer look at how Tailored-LLaMA actually works.
Yes. Let's dive into the mechanics of this approach. One of the key aspects is how they identify the most important parameters to prune.
Okay.
They do this by analyzing the interdependence between different parts of the LLM, almost like mapping out the connections in a complex network.
So it's not just randomly snipping away a connection.
No, it's a very calculated and strategic process. They use a concept called a dependency graph to visualize these connections. Think of it like a family tree for the LLM,
Okay.
where each parameter is a member of the family and the branches represent their relationships.
All right.
They can then identify groups of parameters that are tightly interconnected and evaluate the importance of each group based on how much they contribute to the model's overall performance.
So it's kind of like figuring out who the key players are in a team
Right.
and who might be, shall we say, less essential to the team's success.
Precisely. And once they've identified these groups, they can start pruning away the ones that have the least impact,
Makes sense.
making the model smaller and more efficient.
So they're basically figuring out which parts of the AI are the real MVPs
Right.
and which ones are, I don't know, riding the bench.
Yeah, and they use some pretty clever math to figure that out. They
Yeah.
look at how much the model's error changes
Uh-huh.
when they remove a particular group.
Okay.
If the change is small, it means that group wasn't that important.
So it's like a detective, looking for clues,
Right.
except the clues are hidden in the model's, like, mathematical structure.
Exactly. Now, once they've pruned the model,
Yeah.
they move on to the fine-tuning stage,
Okay.
where they use those task-specific prompts we talked about earlier.
Right.
And to make this process even faster, they use a technique called LoRA,
LoRA.
which stands for low rank adaptation.
Okay. Break that down for us.
What exactly is LoRA and why is it so important here? Well, think of it this way.
Okay.
You have a giant house, but you only need to redecorate one room.
Right.
LoRA is like a shortcut
Okay.
that lets you do just that,
Gotcha.
saving you a ton of time and effort.
So instead of like renovating the entire house,
You got it.
they're just focusing on the areas that need like a refresh.
Exactly. This makes the fine-tuning process much faster and more efficient.
Makes sense.
Especially when working with these pruned models, they're already smaller than their original counterparts.
Yeah. I'm curious, how did they actually test out Tailored-LLaMA? Like, what kind of tasks do they give these pruned and fine-tuned models?
They really wanted to put these models through their paces.
Yeah.
So they tested them on a variety of tasks, all related to common sense reasoning.
So we're not just talking about generating text,
No,
but actually seeing if the model can understand and reason about the world around us.
precisely. They use some well-established data sets like PPyQA, HelloSwag, BoolQ, and Bueno Grande, all of which focus on different aspects of common sense reasoning.
Okay, so they're basically testing the AI's ability to, I don't know, think logically, solve problems
Uh-huh.
using real-world knowledge,
Exactly. And they even included OpenBookQA,
like book QA.
which is based on answering questions from open book exams.
Okay.
These data sets, they present different challenges for the LLMs, requiring them to understand, nuanced language, make inferences, and apply their knowledge in various ways.
That's quite a test.
Yeah.
And how did Tailored-LLaMA perform? Did it like hold up against these challenging tasks? The results were impressive.
Yeah.
Tailored-LLaMA consistently outperformed other fine-tuning methods,
Interesting.
particularly in something called the recovery rate.
Recovery rate. Okay, what's that?
It tells us how much of the model's original performance was restored after pruning and fine-tuning.
Okay.
So, for example, with a 20% pruned model,
Right.
they were able to achieve a recovery rate of 95.68%.
So even though the model was 20% smaller,
Right.
it was still performing at almost 96% of its original capacity.
That's right.
That's pretty amazing.
It is. It shows that you can significantly reduce the size of these models without sacrificing much performance.
But we can't forget about the role of those task-specific prompts.
Of course not.
Did they play a big part in these impressive results?
Absolutely. The research showed that using prompts tailored to the specific task consistently led to better performance
Okay.
compared to using, more general prompts.
So it's like they figured out the secret language to unlock the AI's full potential?
You could say that. And here's the best part. Fine-tuning these pruned models took less than an hour
Wow.
on a single GPU.
That's amazing.
This highlights just how efficient the Tailored-LLaMA approach is.
Yeah.
I mean, that's mind-blowing. It suggests that this technology could be within reach for, a much wider range of applications.
Right.
But I'm also wondering, this paper focused specifically on the LLaMA model.
Yeah.
Do you think these techniques could be applied to other large language models too?
That's a great question. And the researchers They addressed that in the paper.
Yeah.
They believe that the tailored llama approach, it could be generalized to other LLMs,
Okay.
even those with different architectures and sizes.
So it's not just a one-off solution for a specific model, but a potential blueprint for making all sorts of LLMs more efficient and adaptable.
Exactly. Now, they did say more research is needed to confirm this,
Of course.
but the initial findings are really encouraging.
Well, that's certainly an exciting prospect. We've covered a lot of ground here. So let's take a moment to recap the key takeaways from our deep dive into Tailored-LLaMA. So to sum it all up, we've learned that these massive large language models, as cool as they are, don't have to be quite so massive.
Right. Tailored llama shows us we can make them smaller, more efficient, but without losing any of their smarts.
It's like finding a hidden superpower of efficiency.
Within these already powerful AI systems.
And a big part of that is being super specific with, what we ask them to do.
Right.
That prompt engineering we talked about.
It really highlights how important communication is, even when you're dealing with like a cutting-edge AI.
Yeah.
It's about understanding how the model thinks and tailoring our instructions to get the best possible results.
Absolutely. And then there's that few-shot learning.
Right.
Teaching the AI new tricks with just a handful of examples.
Which is pretty similar to how we humans learn best, right?
Yeah.
Sometimes a few well-chosen examples, they're more effective than a whole encyclopedia of data.
Totally. So to recap, we can make LLMs smaller, smarter, and faster learners.
Right.
Which begs the question, what does this all mean for the future?
This research, it's like opening a door to a whole new world of possibilities.
Okay.
Imagine AI tutors that adapt to your, individual learning style.
Yeah.
Super efficient AI assistants that actually help you.
Instead of just being gimmicky.
Right. And just totally new ways to express your creativity that we can't even conceive of yet.
And all of this is possible because we figured out how to, communicate with AI more effectively.
Right.
Train them in a smarter way.
Exactly. This paper on Tailored-LLaMA, it's just the beginning. It's a glimpse into a future where AI isn't this distant, expensive technology,
Right.
but something that's personalized, adaptable, seamlessly integrated into our everyday lives.
It makes you wonder, if we can already do this much with LLMs, what will the next 5 or 10 years bring? What new problems will we solve? What, incredible new creations will we see? All because we took the time to understand these AI systems on a deeper level.
It's an incredibly exciting time to be alive.
I agree.
The future of AI it's unfolding right before our eyes, and research like this, it gives us a front row seat to this revolution.
And that, my friends, is what makes these deep dives so worthwhile.
Absolutely.
Until next time, stay curious, keep asking questions, and we'll see you back here soon for another fascinating exploration into the world of knowledge.